At what rate does a 1,000 Newton box accelerate if the net force acting on the box is 50 newtons to the right? And so I've highlighted 50 newtons here because we know that that's our net force. The first thing that we're going to do is draw a free body diagram, because drawing a free body diagram gives you a better idea of what's going on in this situation. So let's start by drawing our box. Information that I know about the box is that it has a weight, which is in the downward direction. And in this situation, our box has a weight of 1,000 newtons. In order for that box to not go through the floor, because that's what's normal, we have a normal force in the upwards direction of the same value as the weight in the downwards direction. Other information is that I have a friction force, and let's call that X because we don't know that there's a value to it or what that value is. And then a slightly larger than friction, I have a force in the rightwards direction. We're going to call this applied. And this is what's making our box move to the right or to accelerate to the right. And we're going to call that X plus 50 newtons. And we call it plus 50 newtons because that net force of 50 newtons is to the right. All right, now we need to figure out what equation we're using. If you think back to our equation, F is equal to AM. In this situation, we need to solve for acceleration, which means we'll take each side divided by m, and those will cancel out. We get A is equal to force over mass. Now let's list our variables so we can plug some stuff in. So A, F, and M. We know right away that the acceleration is what we're looking for. Force is 50 newtons to the right? That 50 newtons is the net force total, so 50 newtons goes here. And mass we don't know yet. What we have right here is a weight, which is very different than mass. And so our equation for mass, if that's what we're looking for, we think back to W equals mg, weight is mass times gravity. If I divide each side by g for gravity, I end up with my equation of m is equal to W over g. If I'm going to solve for mass, I have a weight of 1,000 newtons divided by my gravity of 9.8 meters per second squared to give me a mass in kilograms. If you plug that into your calculator, you get 102.04 kilograms. Now I can list that up here. Now I'm ready to solve for my acceleration. I'll solve for that over here in green so we don't get confused with what's what. So A is equal to 50 newtons divided by 102.04 kilograms. The acceleration of this object, of this box, is equal to 0.49 meters per second squared.